Dear students, welcome to my channel HSC English version BD. Today we are going to learn how to solve problems on gradient, divergence and curl. Before solving problems, we need to know some basic ideas about vector operator and the power rule of differentiation in calculus. If we can get a crystal clear idea about these two concepts, then solving problems on these three quantities will be very easy for us. So, let us start with this vector operator first. See, there are two words here. One is vector and the other is operator. What is an operator? An operator is nothing but a symbol. It has no meaning of its own. Not only that, an operator doesn't signify any meaning too. But when an operator acts on different quantities like this gradient or this divergence or this curl, then the operator can produce a value. Look at this square. This square is an operator. It has no meaning of its own and even it doesn't signify any meaning too. Now look at here. 5 square equals 25. Individually, this square has no value of its own. But when it acts with this quantity, then this square produces this value. That means this square can only operate or transform a quantity to another quantity. That is why this square is called an operator. For the same reason, square root, cube, sine, cos, tan, log, etc. are called operators. Now we know what an operator is. Similarly, vector calculus has a fixed operator which is called vector operator or vector differential operator. We express vector operator like this. The name of this symbol is nabla or del. Again, this nabla can be expressed like this. Vector operator equals del x I cap plus del y j cap plus del z k cap. These three quantities are formed with the help of this operator. Now we will learn the power rule of differentiation in calculus. Look at this formula. d dx x to the power n equals n x to the power n minus 1. This n is the power of this variable or quantity. According to the power rule, we take this power and write in front of this quantity. Then we reduce the power by 1. Now we will understand some examples from primary level to advanced level on this power rule so that we can get a clear idea about how does the power rule work. Look at this first example. d dx x to the power 6. Suppose we want to differentiate this x quantity according to the power rule. We will write this power in front of this quantity like this and reduce this power by 1 like this. After calculation, we will get d dx x to the power 6 equals 6 x to the power 5. Now look at this second example. d dx 2x cube. We want to differentiate this quantity according to the power rule. Therefore, we will write this power in front of this 2x like this and then we will reduce this power by 1 like this. After calculation, we will get d dx 2x cube equals 6x square. This is our third example. D dx 2x cube y z square. See, in this first example, we differentiated this x with respect to this x, and in this second example, we also differentiated this x with respect to this x. But in this third example, there are x, y and z here. So what will we do now? Actually, we will have to differentiate here only this x with respect to this x, because with respect to this x, only this x can be differentiated, not this y or this z. If there were y here instead of this x, we then differentiated this y with respect to this y, not this x or this z. Similarly, if there were z here instead of this x, we then differentiated this z with respect to this z, not this x or this y. So, according to the power rule, we can write d dx 2x cube y z square equals this power 3 times this 2x to the power 3 minus 1 y z square, that is 6x square y z square. Now look at this fourth example. D dy 3x square y cube z to the power 4. As y is here, so we will have to differentiate this y cube only with respect to this y, not this x square or this z to the power 4. Therefore, according to the power rule, we will write this power of y like this, times this 3x square times y to the power 3 minus 1 times z to the power 4, that is 9x square y square z to the power 4. Look at this example number 5. D dx x cube y plus 2y minus 3z. This example is totally different than these examples because of this positive and negative sign. So the calculation of this example will be different. Now we are going to differentiate these three quantities with respect to this x. See, x is absent here in these two quantities. If an expression with respect to which it is to be differentiated is absent, then the value of that expression becomes 0. Therefore, the value of this 2y will be 0 here, and the value of this 3z will also be 0 here. So, we can write d dx equals this power 3 times x to the power 3 minus 1 times y plus 0 minus 0, that is 3x square y. For better understanding, look at this another example. D dz x cube y plus 2y minus 3z. See, we are going to differentiate these three quantities with respect to this z. But there is no z here with this quantity, and there is no z here with this quantity also. So the value of these two quantities will be 0. Again, see, z has no power here. That means the power of z is 1 here. So we can write d dz x cube y plus 2y minus 3z equals 0 plus 0 minus 1 times 3 times z to the power 1 minus 1, that is minus 3z to the power 0. We know that something to the power 0 means 1. Therefore, we can write minus 3 times 1, that is minus 3. Since we have already got the basic concepts of solving problems on gradient, divergence and curl, therefore let us start solving the problems on gradient first. Gradient is nothing but the simple multiplication of vector operator and a scalar function. That means if we simply multiply this vector operator nabla with a scalar function that is phi like this, then we will get the gradient of this function. Suppose phi equals 2x cube y plus 2z is given in the question paper and we are asked to determine its gradient. See, this is a scalar field as there is no I cap, j cap and k cap here. We know that nabla equals del x I cap plus del y j cap plus del z k cap. Now we will multiply this scalar field with this vector operator like this. Nabla phi equals del x I cap plus del y j cap plus del z k cap times 2x cube y plus 2z equals this del x I cap times this 2x cube y plus 2z plus this del y j cap times this 2x cube y plus 2z plus this del z k cap times this 2x cube y plus 2z. Just a simple multiplication we have done here. Look at this format now. Can you tell me which format is this? Yes, this is differentiation power rule format. Now we will have to differentiate this quantity with respect to this x, this quantity with respect to this y and this quantity with respect to this z. See, here in this quantity this x is present. So we can write this 2 times this power 3 in front of this x, this power 3 minus 1, that is 2 times this y. The value of this 2z will be 0 as x is absent here. So we will write here 0 with this plus sign times I cap plus, see, this is y and this y is present here with this quantity. So we can write this 2x cube times 1 times y to the power 1 minus 1, that is 0 plus, see, y is absent here with this quantity. Therefore the value of this quantity will be 0 here. So we will write here 0 with this plus sign times j cap plus, see, this is z and z is absent here with this quantity. Therefore the value of this quantity will be 0. So we will write here 0 plus, see, z is present here. So we will write 2 times 1 times z to the power 1 minus 1, that is 0 times k cap equals 6x square y I cap plus 2x cube j cap. We know that something to the power 0 means 1. So we need not to write 1 here. Plus we will write here only 2k cap for the same reason. This is the gradient of this scalar function. Now look at this important example. If phi equals 2z minus x cube y, then find the gradient of phi. What is the gradient of phi at point 1, 1 and negative 1? See, here in this question we are asked to determine the gradient of this scalar field, and in this question we are asked to find out the directional derivative of the gradient at each of these points. We have already learned how to calculate the gradient from a given scalar field. So I have written the answer of this first question here directly. I did simple multiplication here and got this differentiation format. By using power rule here, I got this answer. This is the gradient of this scalar field. Now from here, we will have to find out the answer of this second question. Look at this point. This one is the value of x, this one is the value of y, and this negative one is the value of z. There is no z here, so we will forget about this negative one. If we put this one instead of this x and this one instead of this y, then we will get our answer. Therefore, we can write at point 1, 1 and negative 1, the gradient of phi equals minus 3 times 1 square yi cap minus 1 cube j cap plus 2k cap. That is minus 3i cap minus j cap plus 2k cap. This is our answer for the second question. Now we will learn how to solve the problems on divergence. Look at this word divergence. This word starts with the letter D. There is another word which starts with this same letter D, and the word is dot multiplication. Actually, to determine divergence, dot multiplication is needed between vector operator and a vector field. Seeing the presence of I cap, j cap or k cap, we can easily recognize a vector field. Look at this question. See, this is a vector field because unit vectors I cap, j cap and k cap are present here. We are asked to determine the divergence of this vector field here in this question. See, I have written the answer of this first question here directly. I did dot multiplication here and got this differentiation format. If you want to learn the process of dot multiplication and cross multiplication of two vectors in an easy way with full of explanation, please watch my tutorial HSC Physics First Paper Chapter 2 Vector Part 2. I applied power rule formula here in this differentiation format and got the divergence of this vector field. According to this second question, now we will have to find this divergence at this point. This one is the value of this x and this x. This negative one is the value of this y and this y, and this one is the value of this z. If we put this value of x, y and z here instead of this x, this y and this z, then we will get divergence of this vector field at point equals 3 times negative 1 times 1 cube plus 4 times 1 times negative 1 minus 1 cube times minus 1 whole square. That is minus 3 minus 4 minus 1. That is negative 8. This is our answer. Note that if we would get the divergence 0 here instead of this divergence, then we would say that this vector field is solenoidal. Look at this picture. Fluid is entering through these 2 points, but the same amount is leaving through this point. That is, in this case, divergence equals 0, or we can say this is 0 divergence. There are more 2 types of divergence available: positive divergence and negative divergence. See, from this point, all the lines are spreading out. This is the main theme of positive divergence. And see here, all the lines are coming towards this point. This is the main theme of negative divergence. Now we will learn how to solve the problems on curl. Look at this word curl. This word starts with the letter C. There is another word which starts with the same letter C, and the word is cross multiplication. Actually, to determine curl, cross multiplication is needed between vector operator and a vector field. Look at this question. See, this is a vector field. We are asked to determine the curl of this vector field here in this first question. See, I have written the answer of this first question here directly. I did cross multiplication here and got this differentiation format. I applied power rule formula here in this differentiation format and got the curl of this vector field. According to this second question, we will have to find this curl at this point. If we put this value of x, y and z here instead of these x, these y and these z, then we will get curl of this vector field at point equals minus 2 cap. This is our answer. Note that if we would get the curl 0 here instead of this curl, then we would say that this vector field is irrotational. If you like this tutorial, then please don't forget to press the bell icon so that you can get all the new notifications. Thanks a lot for watching this tutorial.